Okay. Oh, what? She what? All right. Here you go, guys. So notes 3, right triangles, unit, circle, sine, and cosine. Relax. You already know about right triangles. We didn't ask any questions last time about 30, 60, 90, 45, 45, 90, but we did this time. I put it on the delta. So hopefully you remember. So let's see if we can tackle these type of questions. If my computer decides to work. And I think it, yeah, there we go. Come on, buddy. Okay, well, that works, I guess. All right, here we go. In a 30, 60, 90 triangle, so here's 30, 60, 90, I have n square root of 3, and 2n. Do you guys remember that? Perfect. Right now I have this 6 here, and it's opposite that 60 degrees, so that 6 belongs right below that n squared of 3. Are we okay so far? Perfect. So if I want to figure out what x is, this is my hypotenuse. I need to figure out the short leg. The short leg is this guy opposite the 30 degrees. So I'm going to go n squared root of 3 equals 6. So how do I get the short leg from that? Not square both sides. I got to get n by itself, right? So I got to divide both sides by square root of 3. So now I have n equals 6 over square root of 3, and we practice rationalizing it. So I'm going to multiply that dude by square root of 3 over square root of 3, which is just the same thing as 1, right? So I have 6 square root of 3 over 3. Hopefully we're getting good at this now. What is 6 divided by 3? So this is nothing more than 2 root 3, or 2 square root of 3. So I'm going to put 2 square root of 3 right here. That's not what I wanted. I wanted the hypotenuse. So to get the hypotenuse, I just double it. So 2 square root of 3 times 2, the square root is unaffected. What's 2 times 2? So 4 square root of 3. And there it is. That's what I would type. If this were a delta assignment, I would type that. If this were a free response question, I would just type it like this. And then just read the directions. You're going to see some of them want it in radicals. Some of them want it to the nearest tenth. So just use your calculator. All right. This one down here is a 45, 45, 90 degree triangle. All 45, if it's an isosceles right triangle, isosceles, because they're going to give you this literature or this, this wording on your delta. Isosceles right triangle. An isosceles right triangle is a 45, 45, 90. That's the only way it can be an isosceles right triangle. Because one of the angles is 90 degrees, the other two angles have to be 45, because you got 90 left for your sum of the interior angles. Has to add up to 180, right? Okay, here we go. In a 45, 45, 90, do you guys remember not necessarily my formula, but, well, I guess it is, it's a formula, but do you guys remember the pattern? No? N, not x squared, n with something on the side. Radical 2 or square root of 2. Radical 2, square root of 2, both the same language. Cool or not cool? Cool. All right, here we go. I have this guy square root of 5, so then this guy must also be square root of 5. So to get the hypotenuse, I take my square root of 5 and I multiply by the square root of 2. They're both under the same house. They're both under the radical, so it's going to stay a radical. Square root of 10. It does not break down. 10 is just 5 times 2. 5 is a prime. 2, there it is. Like, we're done. Cool or not cool? All right. I think we're good. And now we go into this. Is it time to talk about it? Yeah, it's time to talk about it. Okay, so check it out. I'm going to draw, let's see, what am I going to draw? Okay, I'm going to draw the first quadrant, and I'm just going to draw the first part of the unit circle, which I know you have it down here, but that's for a reason. And I'm going to put a random angle, like so. And do you guys see this triangle that I'm trying to draw in black that it has not, there we go. Do you guys see that triangle in black? Yay. And I'm going to label this coordinate way up there. That is some type of, that's some x coordinate, that is some y coordinate. So this distance, you know what, let's color code it. This distance here, somebody, hold on, see if I can reset. This distance here in sky blue This isn't here in sky blue. That's this x distance. That's called, sometimes they call that a horizontal displacement. Have you guys talked about displacement in physics yet? Okay. Sometimes they call that a horizontal displacement. This right here in, my brain wants to say lilac. Is lilac a color? Yes. Is this a lilac color or am I totally off? Yes. Okay. I didn't know. The brain is so weird. I think all brains are weird, not just my brain. I just random. Okay, anyways. That's called a vertical displacement. So that y value is dictated by that coordinate y. So there it is. I color coded it. Are we okay so far? All right. Then we're going to take, let's see, our SOHCAHTOA here. SOHCAHTOA. And I'm going to go ahead and give this a name. This is the unit circle. So the unit circle has a radius of 1 because it's called a 1 unit circle or just unit circle. So the radius is 1. So because from the origin to this part of that circle, that's 1. So my hypotenuse is 1 because my hypotenuse is my radius. Do you guys see that? Okay, perfect. So let's go ahead and use this SOHCAHTOA stuff here. So I'm going to go back to a neutral color. I'm going to write sine. I'll use it in red. Sine of this angle here, is opposite over hypotenuse. Well, opposite is my what? What letter do you see? Y over 1. So isn't y divided by 1 the same thing as just saying y? So anytime we say sine, we're going to use the y coordinate of the unit circle. Cool or not cool? Cool. So now let's go to cosine. I'm going to go to the other side. Cosine of that angle is adjacent over hypotenuse. Adjacent is x, hypotenuse is 1. So x over 1, that is just x. So every time you see cosine of some angle, you're going to give me my x coordinate. Don't worry, we'll do some practice in a little bit. And then finally, tangent. Tangent of that angle is opposite over adjacent, so I see y over x. Are you guys okay? Yes. Perfect. All right. Now we're going to go down to this dude. And don't worry, we're going to reference where we can. And you see that degree symbol? Those are special angles. That's 0. This one's going to be 30. This one's going to be 45. This one's going to be 60. And this one way up here is going to be 90 degrees. Remember that we said the radius of the unit circle was 1? So this coordinate right here is 1, 0. This coordinate up there is 0, 1. Because the radius is 1. Right? The radius of this circle. All that distance there. Yeah. Okay. This other gap that you see is for radians. This is 0. And do you guys remember how many radians is 30 degrees? I don't know why I said it with a little accent there. How do I convert degrees to radians? Yep, 30 times pi over 180. So 3 goes into 18 6 times. So that's pi over 6. So this one here is pi over 6. See? Using that same logic, I go 45 degrees times pi over 180. 45 and 45 is 90, so that means 45 goes into 180 4 times. So this is pi over 4. Yeah, that's what we've been doing all this time when we convert. 60 degrees times pi over 180. So 66 goes into 18 3 times, so this must be pi over 3. So 60 must go into 180 3 times. 60, 120, 180, it does. So this guy right here is pi over 3. And then at 90 degrees, that's just pi over what? You guys remember? 2, pi over 2. You could also do the same thing. 90 degrees times pi over 180. And 90 goes into 180 twice, see? Same thing. How are we feeling so far? Yeah, all right. Don't worry, we'll still feel good, at least I hope, I don't know. I'm going to use burnt orange. Do you guys see this burnt orange triangle right there? That burnt orange triangle this degree here is 30 degrees. And this degree way up here is 60 degrees. That's a 30, 60, 90. That's why they call this 30 degrees here, because from the origin to the x-axis, or the x-axis to the hypotenuse, or your radius, or I guess, yeah, let's call it hypotenuse. That's a 30-degree angle, see? 30 degrees. Cool or not cool? All right, so check it out. We know for a fact that that radius is 1. So if my radius is 1, that means my hypotenuse is 1. Are we cool with that? Okay, so I'm going to draw 30, 60, 90 over here, just like we did a little while ago. And I'm going to say, well, I guess my laptop doesn't like it. Is it going to let me write? Control-Delete should fix that. Bam. And I'm going to say n square root of 3, 2n. I'm going to put the 1 under the 2n. So then that means my short leg better be 0.5. Instead of saying 0.5, I'm going to say a half fraction. Does everyone see how I got the half? Okay. Now, my long leg better be 1/2 times square root of 3. But don't write it like that. Write it like this. Square root of 3 over 2. See? 1 times square root of 3 is square root of 3. Okay, I'll write it over here. 1/2 times square root of 3. Imagine that square root of 3 has like a 1 in the bottom. 1 times square root of 3 is square root of 3. 2 times 1 is 2. So square root of 3 over 2. Yes, miss? Oh, because my radius is 1. And my radius is my hypotenuse. Do you see that or no? Okay, good question, good question. All right, check this out. You guys ready? What is my short leg? The x or the y? The horizontal displacement or a vertical displacement? Vertical. So this distance is half. So you're going to put a half on the y value. Do you guys see how we did it? Okay. My long leg is this distance is the horizontal displacement. So my long leg is the x value. So I'm going to write square root of 3 over 2 for the x coordinate. Does that make sense to everyone, guys? Okay, perfect. I see another 30, 60, 90 triangle. Do you guys see another 30? I feel like Dora the Explorer. Do you guys ever watch Dora the Explorer? That's how she exactly talks. I see. I'll stop. And then, then she's like, do you see? And, okay. This angle there is 60 degrees. This angle here is 30 degrees. So now, notice that your short leg and long leg switch. Or your x and y switch. Does that make sense? I'll wait. So now, what's my x coordinate? The half. The short leg is your x coordinate now. See? This aims towards this guy. There's my short leg. And now that's a half. Yeah, ask. Where did the half come from? 36, 90 triangle. The hypotenuse is 1. So the short leg has to be a half. See? No, keep asking, miss. So what's my y coordinate now? There you go. We just have one more to go. Yeah, the radius has not changed. Look, all these are like radius. Do. Yeah. Good job, miss. Good job. All right, the 45, 45, 90. I'm going to come back over here. And I'm going to say this is like 45 degrees. See? So I'm going to write n, 45, 45, 90. I'm going to put it over here because I have room here. n square root of 2. I'm going to put that 1 below the n square root of 2. Are we okay? So I'm going to write n square root of 2 equals 1. How do I get n by itself? Dividing by radical 2 by square root of 2. N equals 1 over square root of 2. I will accept this. I have no problem with it. But Delta Mass will not. They want you to rationalize the denominator. So what do? Multiply that sucker by square root of 2 over square root of 2. Make sure you rate square root of 2 over square root of 2 because that's 1. Anything times 1 is itself, right? So if you just tell me square root of 2, that's magic because now you're just... Okay, here we go. Square root of 2 over 2. There it is. That's what both of these legs are. So the x and the y coordinate, that's what you call If you have a hypotenuse, you call the other two sides legs. The x and the y coordinate are both going to be the same value, which is what? Square root of 2 over 2, square root of 2 over 2. Let that line be the fraction line, and I feel like it makes it prettier now. And look at all the work you've done, guys. Yay, congratulations. Say it.
So, where you do that purple line, the horizontal line, all that would be square root of 2. Would that be like where?
Oh, yes. Well, this distance. Let me choose black. This distance here. Come on, buddy. Are you going to write? This distance here in black. That's distance is square root of 2 over 2. And so is this distance. Cool? No problem. Check out my 3 triangles, guys. Do you guys see them? One's burnt orange, one's black, one's lilac. Okay. Here we go. Oh, okay. Sorry, was that you? Oh, sorry, Lazardi. I just knew it was coming from this direction, but I didn't know if it was Cruz or Lazardi over there. Or is it Kyle? See, I got you guys all down. Okay. All right, check it out, guys. Look at this giant unit circle. Relax. It's pretty straightforward. The seniors over there will let you know that it's not that bad. Right, Hernandez? Right? Okay. So here we go. Let's fill in what we know. What do we know? The distance, the gap between the x-axis and this, those are all 30 degrees. Even though we don't call that a reference angle. Well, that's not a reference angle. So you know what? Let's just do it. 0 degrees, 30, and then the gap between these gaps right here is 15 each. So what's 30 plus 15? 45, and then 45 plus 15? 60, and then 60 plus 30? 90, and it continues with that pattern. What's 90 plus 30? 120, so put 120. What's 120 plus 15? 135. What's 135 plus another 15? 150. 150. What's 150 plus 30? That better be 180, because there it is. That's my linear pair, right? Like, boom, boom, look, that linear line from the 0 to the 180. What's 180 plus 30? 210, countdown city. 210, okay, I'll stop. 210 plus 15? 225. 225 plus 15? 240. 240 plus 30? It better be 270. 270 plus 30? 300. 300 plus 15? 315 plus 15? 330 plus 30? It better be 360. That's how much one revolution is. Do you see how we did it? Okay, here we go. Radians. 0 is 0, so no one's going to ever get that one wrong, I hope. Next one. This one's pi over. You can look at the previous page. 6. What's the next one? Pi over? 4. What's the next one? Pi over? 3. And then 90 degrees is pi over 2. Do you remember what 120 is? If not, we can just figure it out. 120 times pi over 180. So let's see. 12 over 18, that's 2/3. So that's going to be 2 pi over 3. 2 pi over 3. Take a guess for the next one. Or not. Or don't guess if you don't want to. 135 times pi. Yeah, 3 pi over 4. What do you think this one is? Really fast. Did you say 5 pi over 6? No? Okay, you could have, if you wanted to, done 150 times pi over 180, and you will get that 5 pi over 6. But you could have also done this. So check it out. Let me go over here. You could have also done this. You see this gap right here between 180 and 150? Isn't that gap 30 degrees? Okay, let me put it right here. Isn't this gap right here your reference angle? Isn't that 30 degrees? And isn't 30 degrees pi over 6? You're pi over 6 from having a whole pi. No, really, you're pi over 6 from having a whole pi. This is pi for sure. We know that one. So that has to be 5 pi over 6. See, 5 pi over 6 plus pi over 6, that will equal 6 pi over 6. 6 pi over 6 is pi. Do you guys see that? Oh, check it out. Check out this one right here. This guy right here, that's pi over 4. That one in lilac. 3 pi over 4 plus pi over 4 is pi. Do you guys see that? Yeah, look at this burnt orange here for you Longhorns. Look at that right there and burnt, bless you. I don't know, without a cough or a sneeze, I couldn't tell. Look at that burnt orange there right there. Isn't that pi over 3? 2/3 pi plus 1/3 pi is pi. Oh, you don't get what I'm trying to say?
No.
Okay. What I'm trying to say is that you don't have to do this conversion all the time. What I'm trying to say, Houston, is this. You see how this is power? Oh, sorry. I just knew it was coming from over here. You see how it's already how this is pi over 6? 1/6 pi plus 5/6 pi is a whole pi. Because I know for a fact 180 degrees is pi. Like, you know that? Because we use that to convert all the time. Look, pi is 180. Pi over 180. So, or 180 over pi, we're going from radians to degrees. So you know that pi is 180 degrees. So we know, oh, look, we're 30 degrees away from 180, or we're pi over 6 away from pi. So that must be 5/6 pi, because 5/6 pi plus 1/6 pi is a whole pi. So check it out, Lazardi. You're going to answer this one, right? In case you didn't understand, 5/6 pi plus 1/6 pi, that's 6 pi over 6, and 6 pi over 6 is 6 cancels out with pi. What is pi plus 1/6 pi? Because this distance here is 1/6 pi too, right? So make pi like 6 pi over 6. No, just do it in your head. 6 pi over 6 plus 1/6 pi plus pi over 6. Keep the denominators the same. Yes. Look, I'll draw it for you. Just look up. Just look up here. Ready? This is pi, right? Do you agree that the distance from, do you agree that this distance here, this little gap, do you agree that that's pi over 6? So what is pi plus pi over 6? And I'm going to help you out some more. You see this pi? I just go like that, 6 over 6. What's 6 pi plus 1 pi? No. 6 pi plus 1 pi. 6 plus 1. What's 6 plus 1? So 7 pi, keep the denominator the same. 7 pi over 6. So this guy right here is 7 pi over 6. Do you know what the next one is? Keep the denominator the same. That's a 4. What do you think my numerator is? Pi plus pi over 4. What am I going to do with this pi? I need a common denominator, so I'm just going to go 4 over 4. 5 pi over 4. Let's see if you know if you can see the pattern, Lazardi. The denominator for this one is 3. What's my numerator? Yes. 4 pi over 3. Then this one we know is 3 pi over 2. I guess let's do all the radians first. What do you think this guy is? Yeah, tell me how you did it, miss. No, you did it right. I'm not mad. That was not me getting mad.
So basically, I just put in the number, divided it by 180, and then.
Oh, you did it. You just did the conversion.
Yeah, I just did the.
Oh man, miss, I thought you did it this way. I thought you looked at it and thought that was pi over 3. So I thought you were like, well, that's only pi over 3 away from 2 pi, and I know that 6 pi over 3, 6 divided by 3 is 2 pi. Do you guys see that? No? Okay, look at this.
Wait, repeat that.
Yeah, I'm going to repeat it again and again. My denominators stay the same. That's a 4. This denominator here is a 6. Oh, sorry, disregard the 3 there. So check it out. I know that if I do 1 revolution, it's 2 pi. I have a 4 in the bottom. So in order for this to be 2 pi, 8 pi over 4 would have been 2 pi. My reference angle is pi over 4. So 2 pi minus pi over 4, or 8 pi over 4 minus pi over 4 gives me 7 pi over 4. Hopefully I didn't say that wrong. I feel like I did, like I might have. All right, so let me say it again. I know this is 2 pi, 1 revolution, right? So what I'm really doing is this. I'm doing 2 pi, and I'm subtracting my reference angle, pi over 4. In my head, I'm doing a common denominator. You see how that's a 4? I need a 4 in the bottom. So I multiply this by 4, and that's 8. See? So double the denominator and subtract 1. 8 pi over 4 minus pi over 4, 7 pi over 4. Do you see how I did it, Cruz? Okay, tell me what this one is then. I have a 6 in the denominator.
You have a 6 in the denominator. Would it be
Double it, subtract 1 for the numerator.
double? It would be 12. It would be 11.
It would. Tell us how you did it.
You double it and subtract 1.
Okay, yeah, you tell me the same thing. Guys, it's a pattern, guys. 1 revolution is 2 pi. So that's why I doubled the denominator to get my 2 pi. 12 pi over 6 is 2 pi. Does that make sense? And I subtracted 1 pi over 6. See? 12. So you do that forever, all the time in quadrant 4. Double the 4, subtract 1. Double the 3, subtract 1. Do you guys see? Right. And I'm going to pause, time out here. Look, because this can be hard. So this is why I'm going to talk to you about this. All right. You know what? Let's first fill it in, and then we'll talk. All right. We're so close, guys. We're so close. Give me everything in quadrant 1. This was 1, 0. I guess let's just fill in the obvious ones. 0, 1, negative 1, 0, 0, negative 1, and then finally back to 1, 0. In quadrant 1, at pi over 6, what coordinate was that? Square root of 3 over 2, comma, half? At 45 degrees, square root of 2 over 2, square root of 2 over 2. I'm just copying it from the previous page. At pi over 3, or 60 degrees, 1/2, square root of 3 over 2. Yay or nay? Okay. All you're doing is reflecting. Everything in quadrant 1, reflect it. In quadrant 2, your x's are negative and the y's are positive. So at 120 degrees, you put negative 1/2, square root of 3 over 2. At 135 degrees, or at 3 pi over 4, negative square root of 2 over 2, square root of 2 over 2. At 150 degrees, you're going to go negative square root of 3 over 2, positive 1/2. In quadrant 3, everything is negative. Yeah, you don't have to look up, guys. You can just look at your quadrant 1 or quadrant 2 and just reflect. Negative square root of 3 over 2, negative 1/2. Negative square root of 2 over 2, negative square root of 2 over 2. I guess the 5 pi over 4s, all the 45 degrees, all the ones that have a 45 degree reference are the easiest because it's just the same magnitude all the time. At 240 degrees, negative 1/2, negative square root of 3 over 2. At 5 pi over 3. What? What about the first quadrant? In quadrant 2, the x values are negative. You're just reflecting across the y-axis, right? And in quadrant 3, you can just reflect. You can reflect whichever one you want. I guess I would fold the x-axis. It keeps the same magnitudes. It's just that they're both negative now. See? So they don't flip. That one is in reference to this one. See? Same magnitudes. Okay. In quadrant 4, that's the only one we haven't done. The x is positive and the y's are negative. So positive 1/2. Negative square root of 3 over 2. At 315, they're both square root of 2 over 2, but which one's negative? The y. Good job. At 330, the x is square root of 3 over 2. The y is negative 1/2. And then you're back to 2 pi. Look at all this beautiful stuff that you guys just did. Isn't that awesome? Doesn't that look... Guys, talk to your parents about the unit circle. No, for reals. Maybe if they email me or tell me that you guys spoke to them, maybe we'll give you bonus points on your exam coming up or something. What's up? We're good right now? All right, go to the next page. Don't worry, I'll let you guys know well in advance, at least a week ahead before your test. All right, so now what? How do we analyze something like sine of 150? All right, guys, here's how we analyze it. What did you tell me that sine was? Your x or y coordinate? Look at your notes. We said that sine was the what? The y coordinates. Go to 150 degrees on your unit circle. And what is the y coordinate when you're at 150 degrees? And that's what you're going to write. So sine 150 equals 1/2. Make sure to put a degree symbol on the 150. Do you see how we did it? Okay, let's practice. By the way, this is the same as if you ever wondered, I think someone said, where did these numbers come from? So now you know where they're coming from. And I think someone also, I think it was you, Cruz, or I can't remember who. Someone, I'm pretty sure it was, I'm confident it was this class. Someone asked, like, where did these come from? And I told you about the trig ratios, like 30, 60, 90, 45. Was it this class? It wasn't this? Oh, man. Okay. Check it out, guys. Look, if I put my calculator in degree mode and I put sine 150, look, it gives me 0.5. Isn't 0.5 1/2? Yeah, so there it is. All right, let's continue. Sine 60. Look at your unit circle at 60 degrees. What is the y value? That's what you're going to type. 10 of 315. Go to 315. 10 is y divided by x. Tell me the y value. Tell me the x value. I will accept that. Is there a better? I'm going to put okay, the word okay. Okay. Is there a better answer? Yeah, -1. They're both the same magnitude. One's negative, one's positive. The better answer is -1. Better. I'll accept negative square root of 2 over 2 over square root of 2 over 2. I'll even accept if the signs are opposite, like if you have a positive on top and a negative on the bottom. But I'll give you the awkward emoji because it's y over x, not x over y. Okay. Cosine of 330. Go to 330. What did we say cosine was? So give me the x coordinate for cosine of 330. Yes. Sine of 180. Go to 180 degrees. Give me the y value. 0. Cosine of 90. Go to 90 degrees. Give me the x value. 0. Sine of -30. Oh, we've got our first negative angle. Okay, we go to our unit circle. -30 goes clockwise because you guys just did that handout. So -30 is like 330. So there's my -30. I'll go ahead and insert it right here, -30 degrees. So so that's like saying sine. What did I say, sine or cosine? So that's like saying, so I'm going to go ahead and write right here. This is like sine of 330 degrees. They're both the same, which is what? No, it's sine is the y value. Sine is the y value. Sine is the y value, right? Sine theta is equal to y, remember? So I go to -30 and I give the y value. Miss, look, it's right here. Look, you're the one that told me. You told me that sine theta was y. See? You told me this. No, you told me this, miss. Sine is a y, and then you told me that cosine is x. See? So I just went to the -30 and I wrote my coordinate. Look, it's also true. Look, if I take my calculator and I go sine -30, look what happens. Voila. Sine 330. Voila. Isn't that cool? All right, let's continue. Let's continue. Sine 270. Go to 270. What's the y value? -1. Sine of -120. So I'm going to go to my unit circle. 120 would have been right here. So you're going to have to go the same measure. 120 would have been right there in quadrant 2. So I go to -120. So -120 is like positive 240. Do you guys see that? So what is it? Yep. Negative square root of 3 over 2. Tan of 120. Y divided by x. The y value is square root of 3 over 2. The x value is -1/2. And I'll put okay. Is there a better answer? There's a better answer. What's the better answer? Negative. Cancel out the 2's. So negative square root of 3. This is better. Negative square root of 3. Hello. Sine of pi over 3. Go to pi over 3. That's 60 degrees. What's the y value? Perfect. Tan of 7 pi over 4. So that's quadrant 4. The y is negative, square root of 2 over 2. The x is positive, square root of 2 over 2. What do we get? -1. The -1's the better answer. Cosine of 11 pi over 6. Perfect. Sine of pi. Yeah, 0. Cosine of pi over 2. Now we're just switching from degrees to radians, or radians are earlier. Now we're in degrees earlier. Now we're in radians. Cosine of pi over 2. 0. Sine of negative pi over 6. -1/2. Sine of 3 pi over 2. -1. Right? Okay. Sine of negative 2 pi over 3. Negative square root of 3 over 2. Is that what you said? Yeah. Cosine of 2 pi over 3. No. It is negative, though. -1/2. It's the x value at 2 pi over 3, guys. So go to 2 pi over 3, -1/2. Okay, and there it is. You're going to have a quiz on Friday. Hold on, relax. I will drop the first 3. Usually by the 4th or 5th one, everyone's scoring 90 or higher. And it's going to look, how's it going to look? It's going to look like this. The way you're seeing it there, that's how it's going to look. Chubb, how am I going to memorize all those? Okay, here's where I was going to talk to you about it. If you, and Gonzalez and Hernandez can testify for this, if you try to memorize every single little element, I mean, I guess if you're going through the motion, there is something called muscle memory, and that makes it easier. But if you try to memorize every single little element, it's going to be hard. Guys, don't do that. That's not the way, I mean, you can do that, but it's going to burn, you're going to burn out eventually. Here's how you should memorize it. You see patterns. This is pi over 6. So let's look at the radians first. Look, the denominator is always 6 at that location. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. In quadrant 2, the integer is just 1 less because of the reference angle, 5 pi over 6. In quadrant 3, the integer is just 1 more, 7 pi over 6. In quadrant 4, double from the denominator and subtract 1, 11 pi over 6. Do you see the pattern? So, John, why are you telling me the pattern? If I tell you cosine of pi over 6, you're going to tell me cosine is the x value, you're going to tell me square root of 3 over 2, right? Now check it out. What if I told you cosine of 5 pi over 6? Now if you memorize all the little elements, of course, you're going to be like, oh, cosine is square root of 3 over 2. Be smart. All the cosines, these are the only angles I'm going to ask. If you see a 6 in the denominator, all the cosines are square root of 3 over 2. All of them. If I say cosine, that's cosine's x. Now all you got to do is think about what quadrant you're in. So if I tell you cosine of 11 pi over 6, you're going to think, okay, there's a 6 in the denominator, it's cosine, that's the x, square root of 3 over 2. 11 pi over 6, where is it? Quadrant 4. X in quadrant 4 is positive square root of 3 over 2. You see how we're doing it? Like a great allocation. So if you go, if I tell you sine of 5 pi over 6, sine, all the signs with the 6 in the denominator, all of them are half. Is it positive or is it negative? So I tell you sine of 5 pi over 6, you're like, sine is the y value, 5 pi over 6, I'm in quadrant 2. Oh, I'm above the x-axis. Everything in quadrant 1 and 2 for y is positive. So sine of 5 pi over 6 must be a half. Say a half. You see how we're doing it, guys? It's, by the way, for those of you that are in computer science, like the real detail of how memory works, like computer chips, that's exactly how it works. Pop, like they allocate memory. Pretend this is like literal memory. They just stack upon each other. Stack. And if you're trying to reach one of the bottom stacks in computer science, you have to pop the top off and then recall that memory. That's how it works, but just super fast. I don't know, did they teach you that in undergrad or this? I guess that's computer science 2 or computer science 3, the next one. Or if you have parents that are in computer science, tell them like, Dad, I want to know how the x86 architecture works. Or just read it, type in x86 architecture, and you can start reading about how memory works. All of this stuff, all these phones, all this stuff is based off of, anyways, I'll stop talking. It's all code. But guys, be smarter about how you memorize things. Instead of just memorizing random little elements in your brain, of course it's going to be hard if you memorize every little thing. I just want to memorize them all. Don't memorize them all. Know the patterns. Know the critical thinking. Does that make sense, guys? If you do that, you'll be fine. Okay, let me test you. What is sine? Let's do something simple. Sine of 3 pi over 4.
No, radical 2 over 2?
Yeah, positive or negative?
Positive.
Positive. Sine 3 pi over 4. The pi over 4s are the easiest. Pi over 4s are always square root of 2 over 2. Doesn't even matter. Cosine or sine. All you're thinking now is, oh, that's the y value. If he said 3 pi over 4, 3 pi over 4 is in quadrant 2, has to be positive because y is positive in quadrant 2. You guys see? Like how you should be thinking? Yeah, good job. Good job, nerds. Okay. All right. So now, if you at least understood a little bit of what I was talking about, then you're winning. Because I did throw a lot at you. Now, what you need is experience because you haven't even gone to a rodeo yet. So that's what they do in Texas, right? This is not your first rodeo. So now let's get you in a rodeo and let's do some delta math, guys. All right, log into Delta and let's take care of it, and we'll call it a day.